Flaky tests get all the attention. Selector rot gets none, and it is entirely preventable. But in almost every Playwright suite I've reviewed, selector instability is the primary cause of flakiness, and it's entirely preventable. 3 sprints ago, I audited our test suite. 40% of our locators were stable by the definition that actually matters, surviving a UI change without needing to be rewritten. The other 60%, CSS class chains, dynamic IDs, positional XPaths, they worked until they didn't, and when they broke, nobody could immediately tell if it was the app or the test. 2 AI-powered Git hooks later, we're at 87%. Today, I'm walking you through the exact hook architecture, the full code for both hooks, and the numbers after 3 sprints of running this in production. Let's get into it. Section 1. Why this is a strategy problem, not a tooling problem. Playwright gives you excellent built-in locators right out of the box. Get by role, get by label, get by test ID, get by text. The stable ones are right there in the docs. The problem is adoption at scale. When 8 engineers are writing tests across 3 product areas, best practices in a README don't survive contact with the sprint deadline. Someone opens DevTools, finds a CSS class that works right now, uses it, it passes review, it ships. 3 weeks later, a designer renames that class and 5 tests break. You need a system that enforces the strategy automatically, ideally before code ever reaches review. That's exactly what these 2 hooks do. Hook 1 catches bad locators before commit. Hook 2 heals them after failure. Let's build both. Section 2. The locator tier system. Before the code, you need this mental model, because both hooks are built around it. Every locator in your suite falls into one of 4 tiers. Tier 1 is stable, using data-tested attributes, area roles, and accessible names. Get by role, get by label, get by test id. These survive almost any UI refactor, pass silently. Tier 2, acceptable. Semantic HTML with visible text, get by text, pass, but log a note. Tier 3, risky. CSS class chains like .submit, btn.active, warn and auto-suggest a replacement. Tier 4, banned. XPath expressions, positional selectors, block the commit. The hooks enforce this tier system. Now let's look at how they're built. Section 3, code walkthrough. Hook 1, the locator audit. Hook, pre-commit. This runs as a pre-commit hook via Husky. Every spec.ts file in the diff gets scanned before the commit is allowed through. Here's the core classifier. We define banned patterns first to block them immediately. Then we define risky patterns, mostly plain CSS class and ID locators that aren't using the Playwright best practices. The classifier checks banned patterns first. If any match, it is tier 4 and the commit is blocked immediately. Then it moves to risky patterns. Then we check for stable keywords. Order matters because you want the most restrictive rules evaluated first. Now the LLM suggestion engine, the part that tells engineers what to write instead. We pass the bad locator and DOM context to Claude Sonnet. The prompt asks for ranked replacements in a fixed format. That format is critical. The terminal output needs to be scannable in 3 seconds. And the hook runner itself, what actually runs at pre-commit. It iterates through changed files, scanning every line for locator calls. Tier 4, commit is blocked. The engineer sees exactly which file, which line, which locator, and what to write instead. Tier 3 is a warning only. Hook 2, the heal on failure hook, post-run. This triggers when Playwright reports a locator failure, like a timeout or strict mode violation. It extracts the DOM snapshot from the Playwright trace zip. Playwright trace files contain full snapshots at the exact moment of failure. This function finds the failing locator and pulls a 500-character window around it. That's the context Claude needs to generate accurate suggestions. Now the heal function, it uses a locator intent comment convention we enforce in our tests. Without that comment, the LLM is just guessing. With the intent, suggestions are accurate and targeted. And here's what the engineer sees in their terminal within 20 seconds. No auto-replace, the engineer decides. But the decision is now informed and takes 10 seconds instead of 20 minutes of DOM archaeology. The Locator Priority Rule. After 1 sprint, we formalize this in our coding standards. 1. Data tested. 2. Area roles. 3. Visible text. 4. CSS class. 5. XPath. The hooks enforce this. Engineers stop arguing about it in code reviews because the system already decided. That reduction in friction is a massive benefit. Section 4. The numbers after 3 sprints. Let me give you the actual numbers. 3 sprints of data. Selector stability rate 40% to 87%. We measured this by simulating common UI refactors and counting how much of the suite survived. Selector-related test failures, down 73% from baseline. PR review cycles on test files, 2.1 rounds down to 1.3 rounds. New stat locator onboarding time, 2 days down to same day. The hooks carry the mental model so the engineers don't have to from day one. Tier 4 banned locators appearing in new PRs, 18 per sprint down to just 1. That's a 94% reduction in banned locators reaching review. Section 5. The honest caveats. 3 things I want to be straight about. 1. The heel hook depends on intent comments. The locator intent comment convention is not optional. It's what gives Claude the context to suggest accurate replacements. Enforce it before you ship the hook. 2. The pre-commit hook adds 8 to 12 seconds per commit on large files. Most don't notice, but have that conversation before rollout. It's a fair trade. 3. Getting to 87% required a parallel effort with the dev team. The hooks cannot conjure data-tested attributes that don't exist. You need buy-in to add stable IDs. And finally, 100% is probably not the goal. 87% stable with a clear path for the remaining 13% is a genuinely maintainable position. Selector instability is the silent killer of Playwright suites. It's not dramatic. They just quietly break after every UI refresh. 2 hooks, a 4-tier system, and 1 cross-team conversation. That's the entire intervention. 40% to 87% in 3 sprints. The full code is in the description. For the complete Playwright series, visit Automate and Elevate on YouTube. See you in the next one.